Hello, beautiful people. We're going to go ahead and go over homework for notes to part 1. Okay, so this is about solving systems by graphing. In this video, I'll be going over part 1 and part 2. So if it is a little bit longer, I apologize for that. But the notes are kind of quick. All right. So for the warm up, it's just solving the system. Okay, I will lead you to what's method you should use, either substitution or elimination. And then you should be doing those on your own just for some extra practice, okay? So if I look at this, I have 3x minus 2y is equal to 12, and 5x minus 5y is equal to 10. This one doesn't really lead us to anything. Honestly, you can go one of two methods, but just looking at the problem, I think the easiest way is to do elimination. Okay, and I would go for the y's. And the reason why I'm saying the y's is because I have a negative 2y and I have a negative 5y. I can easily get that to be 10. One of them is going to have to be a positive, though. One of them is going to have to be a negative. So I'm going to make the first one be a positive 10 by multiplying everything by 5. And the second one, I'm going to get it to be a positive 10 by multiplying everything by 2. So you should come up with negative 15x plus 10y is equal to negative 60. And then for the second equation, you should have 10x minus 10y is equal to 20. So now you can go ahead and add these two equations together and finish them off. Looking at number 2, this one should be boom right in your face. We have a y equals 2/3 x plus 6, and we have x plus y is equal to 2. So right away, you should see that this should be substitution. Okay, you're going to take this portion here, and you're going to plug it in right there. So you get x plus 2/3 x plus 6 is equal to 2. And remember, try and get rid of that fraction by multiplying everything by the denominator, so you don't have to work with that 2/3 anymore. Okay, so we have a learning outcome, and it's to solve systems of equations algebraically and also graphically. So we just have some definitions that we need to go over real quick. So a linear equation is an equation for a line. And then we have a linear system, which is two or more equations for lines. Okay, so off to the side here, we're going to do like a little example. So for my linear equation, I'm going to go ahead and graph y is equal to 1/2 x plus 3. Right, so that's going to be my first line. I'm going to go ahead and graph that one in purple. So I'm going to start at the y-intercept of 3, and I'm going to go up 1 over 2. And with systems, you need to be very, very persistent with graphing all the way out to the whole entire coordinate plane. So going both directions, because sometimes the solution to the problem doesn't pop up like right away. So you need to be careful that you have graphed it all the way out from left to right, up or down. Okay. Now for over here, the linear system, now we're graphing two lines. So again, I'll have my one I already graphed, 1/2 x plus 3, but in red, I'm going to go ahead and graph y is equal to negative 1/2 x plus 1. And these are just examples. So I'm going to start at positive 1. My slope is negative 1 over 2. So I'm going down 1 to the right 2. And again, both directions. Okay, and I can go ahead and connect those points. So now we're seeing graphically that we have two lines. They're intersecting at one point, okay? And that point, that one point where they intersect, that is our solution, okay? And in this case, it is going to be negative 2, 2, okay? That is the solution right there. That is what we're looking for. And we have 3 different types. We can get one solution, which is this an example. We can get no solution, meaning that the lines are parallel, or we can get infinitely many solutions where the two lines are actually the same exact line. Okay, so what is a linear system? It is a set of two or more equations with the same variables, meaning x and y. Maybe we're talking about m and r, I don't know, but it's going to have the same variables. So the solution to a linear system is the ordered pair that is a solution to all equations in the system. Okay, so the solution is going to be valid for all the equations that are in the system. Okay, and again, it's 2 or more lines put together. Okay, so we have, again, 3 possible scenarios. We can have one solution. Okay, and we're just going to kind of sketch one solution, right? Right here. They cross at one point. Okay, the next type is there is no solution. So we have a line here and we have a line here. These lines are parallel. They're never going to cross. There's no solution to that system. And remember, if they're parallel, they're going to have the same slope. Okay. The last one that we can have is infinitely many solutions. Okay, so if I have this line here, that's my first line. My second line is the same exact line. Infinitely many solutions. So no matter what solution you pick, no matter what point on that line you pick, it's going to be a solution for both of them. Okay, so that's the beauty about graphing, because you can automatically look at a graph and say, oh, it's one solution. Oh, it's no solution. Okay, it's going to be infinitely many. All right, so for example 1, let's go ahead and graph these 2 lines. I'm going to go ahead and do mine in colors. So this is going to be in red, and this one will be in blue. Okay, so in red, -1/2 x plus 4. So I'm starting at +4, and I'm going down 1 to the right 2. And I'm going to keep going, again, in both directions. And once you have draw a straight line, don't be like me. I'm being a little lazy right now, not using my ruler. Okay, blue line is going to be 1/2 x plus 2. So I'm starting at my y-intercept of +2, and I'm going up 1 and over 2. Okay, so we can see where our 2 lines intersect, where they cross at. That is going to be our one solution. So this point right here. Okay, that is 2, 3. So our solution is 2, 3. Okay. Okay, so for the next one, we have 2x plus 3y is equal to 6, -x plus y is equal to -8. So we can either find our x-intercepts and y-intercepts because they're in standard form, or we could change them to slope-intercept form. Okay, in this case, it's pretty easy. I'm just going to go ahead and get the x-intercept and y-intercept. If things ended up becoming like fractions, then I would solve it. Okay, so again, with the x-intercept and y-intercept, I always tell you guys just cover one up and then just solve that. So 2x is equal to 6. Well, that means x is equal to 3. So my x-intercept is 3, 0. For the y, cover up the 2x. So 3y is equal to 6. So 3 times what gives us 6? It's going to be 0. Going to give us 2. So 0, 2. So that's going to be the first line that I'm going to graph, and that's going to be in red. So 3, 0 is our x-intercept, and 0, 2 is our y-intercept. You can see that from these 2 points, we have a slope. We're going to go down 2 and to the right 3. So to get more points, I'm going to just keep following that, down 2 to the right 3. And I'm going to go in both directions so I can get that full line. Okay. The next one is going to be, we're going to do the same thing. Let's cover up the y. So I get negative x is equal to negative 8. Well, we can't have that negative there, so it's actually going to be, our y-intercept is actually negative 1. Because if I multiply negative 1 times negative 1, that's going to give me, wait, I'm sorry. Why am I saying negative 1? I meant it's going to be a positive 8. Okay, so if I plug in 8, negative 8 is equal to 8. So 8, 0. And then my y-intercept is going to be y is equal to negative 8. So it's going to be 0, negative 8. So let's go ahead and plot those 2 points. I'm going to do that in blue. So 8, 0. 8, 0 and 0, negative 8. Okay, I'm going to just go ahead and connect those 2 points. I'm going to go ahead and use a ruler. Okay. And this actually comes out, each of these, the slope is actually going to be 1. So if you look right there. So then where are they intersecting at? What is our solution? That's our solution right there. That is 6 comma negative 2. Okay. I want you guys to go ahead and graph. Find your x-intercept and y-intercept first. So something comma 0 and 0 comma something. Okay, x and y-intercept. This one you can just graph as is. Your y-intercept is negative 5, and you're going to rise 2, run 3. Tell me what the solution is. Okay, same thing with this one. I want you guys to go ahead and do D. So this one you can also get your x-intercept and y-intercept easily. So something comma 0 is the y-intercept, and then 0 comma something is our y-intercept. And then for this one, same thing. You can get your y, and you can also your x-intercept, and you'll also get your y-intercept. Okay, so I'll be checking those because you should be able to graph these now at this point since we've gone over a couple examples. Okay, so I'm going to go ahead and move over to part B of the notes now. So handout or notes 2B. So part 2, notes, homework 4, notes 2, part 2. Okay, I'm going to go ahead and skip the warm-up for time, but you should do the warm-up on your own as well. Okay, so you're just solving by graphing. Looking at these, you can, this one right here is in point slope form. So you're given a point and you're given the slope. Start at that point that you're given and use the slope. Okay, so I'll just kind of help you out. I have the point. It is negative 8, negative 3. So that's where you start, negative 8, negative 3. And the slope is 2, so I'm going to go up 2 over 1. So just keep going. You should be able to graph the other line. Okay. Graph the other line and get the solution. This one, it's in slope-intercept form and standard form, so get your x-intercept and also your y-intercept. Okay. So we have your friend is starting a business and needs to decide between 2 long-distance phone carriers. One company, frequent phoner plan, costs 20 cents for the first minute and 17 cents for each minute after that. A second company, small business plan, costs 50 cents for the first minute and 11 cents for each additional minute. Help your friend decide. So we first need to do a table, then we need to define the variables, the equation, and then we're going to graph. So we're starting with, we always want to look at how much the base cost is. So that's going to be our 0. We know 1, 2, we're going to do cost of the minutes. Okay, so for the frequent phoner plan, it costs 20 cents for the first plan. Okay, first minute, and 17 cents after each minute. So if we're starting at the base, which is 20 cents, okay, and then it's 17 cents. We're going to be adding 17 cents. Okay. And we're going to keep going. For the second company, the small business plan, it costs 50 cents for the first minute, and then it's going to add 11 cents. So 61 cents is the next. So I'm going to just go ahead and do these. I mean, if you were to put this in the calculator, this is what you would get. So when I finish this up, I get, for 7 minutes, it's going to cost $1.39 for the frequent phoner plan. For the small business plan, if I continue, by adding 11 cents, just on this table, you should be able to see something. Something should have came up. You should already see what your solution is, where they're both equal, right? At 5 minutes, they both cost $1.05. Okay, so now what we're going to go ahead and do is we're going to define the variables. So my x is going to be the minutes, and my y is the cost. Okay, we're going to go ahead and do our equations in slope-intercept form. So we know our slope for the frequent phoner plan is 20 cents. I mean, that's our, we know it's 17 cents each minute. So that is our slope. Okay, plus how much did it start off? It started off at 20 cents. And then for each minute after that, it's going to be 17 cents. So for the small business plan, it starts off at 50 cents. And each minute after that, it's adding 11 cents. So that is our slope. Okay. For our graph, we're just going to go ahead and do like a nice little sketch. So I'm going to have this go by 10 cents. So 10, 0.20, 30, 0.40, 0.50, 60. Okay. And then my minutes is going to go by ones. So again, this is cost and this is minutes. 2, 3, 4, 5, 6, 7. Okay. So to start off the graph, the frequent phoner plan, this is going to be in red. So I'm starting off at 0.20 and I'm going up 17 cents. So I should go to 0.37 next, which should be about right here. At 2 minutes, it's 54 cents. At 3 minutes, it was 71 cents. Okay, so that's the frequent phoner plan, FP. And then in blue, I'm doing the small business. So I'm starting at 50 cents. And then I should be at 1 minute, it should cost 61 cents. At 2 minutes, it's going to cost, 2 minutes, it's costing 0.54. Oh, wait, 0.72. Okay. And these are eventually going to cross at $1.05, and I did not accommodate my graph for that. So just know that they should cross. And if you were to do your graph a little bit better than mine, you should see that they're crossing at that 1.05. So find the point of intersection. Again, we already see that on our table. So it's 5, 1.05. Describe what that point represents. So at 5 minutes, both plans charge $1.05. Which plan should your friend choose? Justify your answer. Well, let's look after 5 minutes. So we know at 5 minutes they're both the same. So after 5 minutes, who's actually going to be cheaper? Well, at 6 minutes, the frequent phoner is $1.22. At 6 minutes, the small business plan is $1.16. So obviously, I'm going to tell my friend to go the cheaper route. So my friend should choose the small